Geometry 4-2, angles of triangles. So we're going to look at this triangle angle sum theorem. So if I have a triangle that is triangle ABC, if I were to take the measure of angle A and add it to the measure of angle B and add that to the measure of angle C, I would get 180 degrees. So no matter what the triangle is, if I were to add the three interior angles, I would get 180 degrees. We talked about that just briefly in 4-1, but here we are officially talking about it. All of the angles inside of a triangle, if you add them up, you get 180 degrees. So let's look at an example of a triangle, and let's use our new knowledge of the triangle angle sum theorem. Let's put that to the test here. So this is going to be J, K, M, and from K I'm going to draw a line segment there, and I'm going to have point L here. Okay, angle JKL is 28 degrees. LKM is 71 degrees. KLM is 57 degrees. Now, JLK is angle 1, and down here M is angle 2, and J, or KJL, is angle 3. And I want to know the measure of angle 1, the measure of angle 2, and the measure of angle 3. So let's figure out how we can go about doing this. Using what we just learned, let's find M first. Okay, so I know that 57 plus 71 plus this angle is going to get me 180 degrees. So I can say 57 plus 71 plus measure of angle 2 equals 180 degrees. So 57 plus 71 is 128. 128 plus measure of angle 2 equals 180 degrees. So I'm going to just subtract 128, and I have measure of angle 2 equals 52 degrees. Oops. 52 degrees for measure of angle 2. Okay, let's do this other one now. Okay, now this one I have two angles here. So this would be 28 plus 3 plus 1. And I don't know what either of those are. But I can figure out what angle 1 is. And I can do that by saying that this whole area here, from this side to this side, is 180 degrees. So in order to find 1, I can subtract 57 from 180, and I get 123, and that gives me the measure of angle 1. So measure of angle 1 is 123. So if I add 123 and 28, so like we can do our math this way, but let me just do it another way here to find this measure of angle 3. So we can do this more kind of algebraically, if you want. Or we can do it another way. Let's say 23 plus 28 is, let's say 123 plus 28 equals 151, right? 151. So now I'm just going to subtract, the total is 180 degrees. I'm going to subtract 151 from 180 to find 3. So 180 minus 151, and that gets me 29. So that would be measure of angle 3, 29 degrees. All right, let's do another one, and this one you get to do. All right, now we have kind of a crazy thing to draw here. So we're going to draw a line down here, line across, and a little bit longer line on the other side. And this is V, W, Z, and up on the right is Y. Now we're going to connect W and Y with a line segment, and V and Z with a line segment. Pop. And right here in the middle, this is X. Okay, angle Y is 58 degrees. Angle XZY is 65 degrees. Angle XWV is 67 degrees. Angle W is congruent, or angle, sorry, XWZ is congruent to angle XZW. Okay, now we need to find this angle V is 4, VXW is 5, WXZ is 6, ZXY is 7, XZW is 9, and XWZ is 8. Whew, got a lot of work to do here. All right, so I want to know measure of angle 4, measure of angle 5, measure of angle 6, measure of angle 7, measure of angle 8, and measure of angle 9. Okay, so this is a U-try. So use what we learned up here and see if you can start picking off some of these angles. I suggest if you're having a hard time right at the beginning, find measure of angle 7 first, because you have one complete triangle here and you've got 2 of the measures already. So you should be able to find that other one without much of a problem, and then you can use your angles that are part of a line here to find 6, find 5, all right, and then you can find all the rest of them. Okay, so make sure, pause and get as many of these angles as you can, try to get them all, and then unpause and we'll go over how you did. Go. All right, let's see how you did. So I'm going to go for angle 7 first, just like I said right before I told you to pause. So 58 plus 65, 58 plus 65, that gives me 123. Okay, so 7, angle 7, measure of angle 7, is not 123, right? It's 180 minus 123. Because that 123 is these two. So I need to subtract those, and so I get 57. 57 degrees for measure of angle 7. 57 degrees. All right. Now, measure of angle 6, since this from here to here is 180 degrees, since these are a linear pair, or linear, oh man, I don't know, I've lost all my words. So, anyway, 180 degrees from here to here, this angle. So that means 57 minus 180 is 123. I already know that. So angle 6 is 123. All right, now 5 and 7 are vertical angles. So that means they are congruent. Or I could subtract angle 6 from 180 again and find 57. Either way, angle 5 is 57 degrees. All right, so if angle 5 is 57 degrees, I can find angle 4 by adding angle 5 and this 67 degrees here, and then subtracting my sum from 180 in order to get this angle here, angle 4. So 67 plus 57 is 14,124. So 124, now I'm going to subtract 124 from 180. And I get 56. So measure of angle 4 is 56 degrees. Okay, I have 8 and 9 left. This one's a little bit tricky. Angle 6 is 120 degrees, 123 degrees. So I'm going to redraw this, just that bit of the triangle right here. These two angles are congruent, 8 and 9. And this measure is number 6, 123. Okay. So if I added all of these together, then I would get 180 degrees. And I know that these two need to be the same because they are the same. So I could algebraically say 2 times x, or whatever this angle is, plus this angle, 123, equals 180. I could subtract 123 from each side. I've got 2x equals 180 minus 123 is 57. Then I divide both sides by 2. X equals 57 divided by 2 is 28.5. So that means each of these angles is 28.5 degrees. Another way to think about it is, let's just subtract 123 from 180, and I get 57. And so these two angles have to share this 57 degrees. And since they are congruent, you've got to just divide it straight by 2, and you get 28.5. And so each of these has to be 28.5. That's another way to kind of think about it. It's the same math. It's the same thing we're doing, just a little bit different way to think about it. Okay, just a little bit left to go here. We're going to talk about the exterior angles theorem. Exterior angle theorem. And we're going to draw a triangle like so, with a ray sticking out one side. So this is triangle ABC, and there's this angle here is angle 1. Measure of angle A plus measure of angle B equals measure of angle 1. Why? Let me show you why. Angle A plus measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees, right? So if all of these added up equal 180 degrees, if I were to add these two up and subtract from 180 and find out what this is, right? So if I say 180 minus measure of angle A plus measure of angle B equals measure of angle C, right? 180, if I add these two together and I subtract that from 180, then I get measure of angle C. Now, if I add these two together, or if I take measure of angle C, I should say here, measure of angle C, and I say 180, now I'm talking about this whole line here. This is 180 degrees. And I subtract measure of angle C from it, then I get measure of angle 1. If I subtract 180 degrees. If I subtract measure of angle C from 180 degrees, then I get that piece right there, which is 1. So I could just kind of skip all of this work and just say this one plus this one equals this one. This one plus this one, subtracted from 180, gets me this one. This one, subtracted from 180, gets me this one. And so I can just kind of skip that step and go this one plus this one equals this one. If you can't remember that, it's fine. You can still find this angle and then find this angle later. It's not a big deal. Okay. Here's your example, and we're just doing one, and we're going to be done with this lesson. Find the measure of angle JKL. I've got a line, I've got a triangle sitting on that line, and this is triangle KLM. And this point over here is J. This angle, JKL, is 2x minus 15 degrees. L is x degrees, this angle here, and LMK is 50 degrees. Now, let's use this exterior angle theorem to find out this measure. So we just learned that this one plus this one equals this one. So all we do is say x plus 50 equals 2x minus 15. And then we solve for x, but we want to know this angle, but we got to find out what x is first in order to find that angle. So let's subtract x from each side, and let's add 15 to each side. The x's go away. The 15s go away here. So 15 plus 50 is 65 equals 2x minus 1x is x. Okay, now I just take that x value and plug that into this here to get JKL, because this is the measurement of JKL. So 2 times 65 minus 15 equals, this is 130. 130 minus 15 is 115. 115 degrees is the measure of JKL. And that is the end of Geometry 4-2. Good luck on the homework.